Hello, in this short video I'm going to solve the following problem for you. A certain oscillator satisfies the equation x double dot plus 4x equals 0. Initially the particle is at point x equals to square root of 3 when it is projected towards the origin with a speed 2. What is the amplitude of the oscillations and how long does it take for the particle to first reach the origin? Pause the video at this point and give it a try. If you do the calculations correctly, these are the answers that you will get. Amplitude is 2 length units, and time in which the particle reaches to the origin for the first time is pi over 6 time units. Okay, so if you compare this given differential equation with the standard harmonic oscillator differential equation, which is x double dot omega squared x equals to 0, you immediately realize here 4 playing the role of this omega squared. So omega squared is 4, which means that omega, which is a positive constant, is 2. Okay, and we already know the answer to a generic harmonic oscillator differential equation is a constant A times cosine omega t plus B sine omega t. A and B are constants that should be fine-tuned using the initial value conditions. But of course, let me replace omega with 2 here. So for this problem, x of 2 is A cosine 2t plus B sine 2t. Okay, but it is given in the problem that x of 0, the particle initially is at the square root of 3, and the particle is projected with the speed 2 towards the origin. So this means that x dot, the velocity at time 0, the magnitude is 2, but because it is projected towards the origin in the opposite direction, because you know that the initial value of the position is the square root of 3, so if this is the origin, the initial position is here. When you project it towards the origin, it will be in the opposite, the positive direction of x-axis. So then I have to write minus 2. Okay, so I will apply these two conditions into this equation, and then using that I can find a and b. Okay, so x of 0 is square root of 3. What does it mean? It means that if you replace t everywhere with 0, the answer is supposed to be square root of 3. If I replace this t with 0, this becomes cosine of 0, which is 1, times a is just simply a. And if I replace this t with 0 as well, this becomes sine of 0, which is 0. 0 times b is just 0. So the left hand side becomes a, the right hand side becomes the square root of 3, and we found a. Okay, but now I need to differentiate the function. So x dot of t becomes minus 2a sine 2t plus 2b cosine 2t. So I differentiated these two functions with respect to time. Okay, but now I know that x dot of 0 is supposed to be minus 2. So what does this mean? This means that if I go to this derivative, replace t everywhere with 0, the answer is supposed to be minus 2. If I replace this t with 0, sine of 0, 0, so this vanishes. If I replace this with 0, cosine of 0, 1, so the left hand side simply becomes 2b, and the right hand side is minus 2. Then I can also immediately find that b is equal to minus 1. Putting these numbers back into the original equation, x of t becomes equal to square root of 3 cosine 2t, and then minus sine 2t. Okay, so this is the equation governing the motion of this particle at any instant time t. Okay, but now we want to find the amplitude. So amplitude is simply square root of these numbers squared. This is minus 1. So this becomes square root of 3 squared plus minus 1 squared. So it becomes square root of 4, which is simply 2 as it should be. Sorry. But now we want to see when the particle returns, when the particle is at the origin for the first time. So it means that I am interested in a time for which x of t is 0 and t is the first possible value. Okay? Okay, so I have to solve an equation, a trigonometric equation. So if this is supposed to be equal to 0, then it means that this expression should be equal to sine 2t. So in other words, sine 2t is equal to square root of 3 cosine 2t, and I divide everything by cosine 2t, the left hand side becomes tangent 2t, and the right hand side becomes the square root of 3. I am sure that I can divide by cosine 2t. Cosine 2t is not 0, because if cosine 2t is 0, sine 2t should also be 0, but we know that sine 2t and sine cosine 2t cannot simultaneously be equal to 0. So I'm on the safe side. So I divide everything by cosine 2t, then I get this one. So this means that I get infinitely many solutions. So 2t is pi over 3 plus any integer multiple of pi. I divide everything by 2, so t becomes pi over 6 plus n pi over 2. But because we want to find the minimum possible positive value, positive because time is positive here, and then I want to find the first time that the particle reaches to the origin, so it means that I need to choose the minimum possible value for t. So then it means that I have to choose n equal to 0. Yes, because if I choose a negative number, then t becomes negative. So the first positive value for t is when I choose n equals to 0, and the number will become pi over 6 time units. I hope that this short video was useful for you. Until the next video, be safe and goodbye. Thank you.